Hey everyone, Mr. Houck here. In today's video, we're going to be looking at a second collection of practice problems to help us prepare for a Unit 1A test. Let's go ahead and get started. Number one, we want to select all the following that are true for the right triangle provided. So in the right triangle provided, first off, notice that we are working in degrees. So we're going to have our calculator, whether it's Desmos or the graphing calculator, set to degrees and not radians. So notice that our answer choices, we need to find the value of y, the value of x, the hypotenuse, and the measure of angle B. Well, we can already knock one of these out here. We can see that the 17 is directly across from the 90-degree angle, so that means the 17 is in fact the hypotenuse. So I'm going to go ahead and fill this one in right here, option D, because 17 is the hypotenuse. That is true. Okay, let's work on trying to find x and y. So relative to the 37-degree angle, y is the opposite leg and x is the adjacent. So I'm going to go ahead and label this opposite. I'm going to label this adjacent. And let's go ahead and start working on solving those. So I'm going to start with y. Looking at y, we have the opposite, and I know the hypotenuse is 17, so that tells me to use the sine. So I'm going to say that the sine of 37 degrees is equal to the opposite over the hypotenuse, which is y over 17. Multiply both sides by 17, so y equals 17 times the sine of 37 degrees. And let's see what we get here. Let's open up Desmos, have that running next to us. Okay, first things first, let's make sure Desmos is set to degrees. Okay, now it is. And then we'll calculate 17 times the sine of 37, and we get 10.23. So y is equal to 10.23. All right, that makes A true. Let's go ahead and try to find x real quick. So for x, we know that x is the adjacent leg to 37 degrees. So adjacent and hypotenuse would use the cosine, so the cosine of 37 degrees will equal x over 17. Multiply both sides by 17, tells us that x equals 17 cosine of 37 degrees. Once again, coming over to Desmos here, 17 cosine 37 degrees, we get 13.58. Okay. But notice that C says 14.58, so that must be false. Now let's look at statement B. Statement B says the measure of angle B is 53 degrees. Well, remember that in a triangle, if we add up all the angles, we're going to get 180 degrees. So we already know we have a 90-degree and a 37-degree angle. If I add those together, we're going to get 127 degrees, and then 180, which is the total for the triangle, minus 127 degrees, which again is the sum of these two angles, should give us the measure of angle B, which is 53 degrees. So that statement is also true. Moving on to the second problem. John wants to measure the height of a tree. He walks exactly 100 feet from the base of the tree and looks up. The angle from the ground to the top of the tree is 33 degrees. How tall is the tree? All right, let's draw a picture here. Here's my tree. Okay, we know that the height of the tree, is what we're trying to find, so I'm going to call it x. He walks exactly 100 feet from the base of the tree, so we'll call this leg 100. And the angle from the ground to the top of the tree is 33 degrees. So when we're looking here at our 33 degrees, 100 is the adjacent leg. X is the opposite leg, and we don't know the hypotenuse, which is fine because we don't need it here. We're going to use the tangent. I remember that the tangent is the ratio of the opposite leg divided by the adjacent leg, so the tangent of 33 degrees equals x over 100. Go ahead and multiply both sides by 100, and we get that x equals 100 times the tangent of 33 degrees. All right, let's use Desmos real quick. So 100 tangent, 33 degrees, and we get 64.94 feet. Go away. All right, 64.94 feet. Problem number 3, convert 9 pi over 5 radians to degrees. Keep in mind that 1 radian, let's get auto shape recognizer off, 1 radian equals 180 over pi. So we're going to take 9 pi over 5, we're going to multiply it by 180 over pi. Notice here that pi will cancel, one in the numerator, one in the denominator. We get 9 times 180 divided by 5. And after simplifying, this would turn into 324 degrees. And let's just fact check that real quick. Okay. So again, 9 times 180. Oh, let's try that again. 9 times 180 divided by 5, and we get 324. Excellent. All right, number 4, find the exact value of sine of the inverse tangent of negative square root of 3. Okay, so remember with trig compositions, we want to work with the inside trig function first. So we're going to start with the inverse tangent of the negative square root of 3. And let's go ahead and set that equal to theta. We know that since we're working with an inverse trig function, we're going to get an angle as the result. And this is the same as saying, aka the tangent of some angle theta should equal the negative square root of 3 as long as we're on tangent's restricted domain where theta is in negative pi over 2 to positive pi over 2. So if I hop over to my unit circle here, let's go ahead and work on our restricted domain there. So what I'm highlighting here in blue, that represents negative pi over 2 to positive pi over 2. I'm going to go ahead and convert 11 pi over 6 to negative pi over 6, 7 pi over 4 to negative pi over 4, and 5 pi over 3 to negative pi over 3, just so that we're working with the correct domain, negative pi over 2 to pi over 2. So what we're looking for right now is an angle such that when we take the tangent of that angle, we get negative square root of 3. Well, here's a negative square root of 3 for our tangent value. It's in the restricted domain, and it's coming from negative pi over 3. So that angle that we're looking for is negative pi over 3. So essentially, we have taken care of this inside piece. We found that the inverse tangent of negative square root of 3 is negative pi over 3. Now we need to take the sine of negative pi over 3. Well, remember that the sine value is the y value, and at negative pi over 3, the y value is negative square root of 3 over 2. And that would be our answer. No, for some reason I like it when it does a little shading inside the box. There we go. Negative square root of 3 over 2, which is answer choice C. All right, problem number 4. Which of the following angles below is not a coterminal angle for 5 pi over 7? Well, remember that to find coterminal angles, all we do is we take our original angle and we add or subtract multiples of 2 pi or 360 degrees. Since we're working in radians right now, we're going to add or subtract multiples of 2 pi to 5 pi over 7. Now, before I add 2 pi to 5 pi over 7, let's go ahead and rewrite 2 pi so that we have a denominator of 7. So I'm going to say 2 pi equals 14 pi over 7. So again, 14 pi over 7 is 2 pi, but I'm writing it in a way so that I have a common denominator of 7. So let's go ahead and start adding first multiples of 2 pi to 5 pi over 7. So here's our 5 pi over 7. Let's go ahead and add 14 pi over 7, aka 2 pi. And we would get 19 pi over 7. And I'm going to go ahead and circle that because that is one of our coterminal angles. So we know that 19 pi over 7, that is a coterminal angle. We're not going to select it because we're looking for the angles that are not coterminal. Okay, let's go ahead and add 19 pi over 7 again. Or not 19 pi over 7, but rather 14 pi over 7, aka 2 pi. So 19 pi plus 14 pi, that's going to give us, what, 33 pi over 7? I'm going to circle this because this is one of our coterminal angles. If you look at your answer choices, though, notice that 25 pi over 7 is definitely not going to be coterminal, because after 19 pi over 7, 33 pi over 7 is the next coterminal angle when you're adding 2 pi. So B is not going to be coterminal. Let's go ahead and check C and D. So notice that both C and D are negative angles, so we don't need to keep adding 2 pi or 14 pi over 7. Now let's go ahead and start subtracting 14 pi over 7. So we have 5 pi over 7, our starting angle. Let's go ahead and subtract 14 pi over 7 now. So 5 pi minus 14 pi, that's going to give me negative 9 pi over 7. Circle that because it's a coterminal angle. Notice that that is answer choice C. All right, well, let's continue to subtract 14 pi over 7, aka 2 pi. Negative 9 pi minus 14 pi, that's going to give me, let's see here, negative 23 pi over 7. Circle that because that's a coterminal angle. And then let's subtract 14 pi over 7 one more time. Negative 23 pi over 7 minus 14 pi over 7 is going to be negative 37 pi over 7. And notice that that is answer choice D. And real quick, made a small mistake. We don't want to select answer choice C. We only want to select the ones that are not coterminal. All right, and our last problem here on the shorter review, given that the cosine of theta is negative 3/8 and that theta is trapped between pi over 2 and pi, find the cotangent of theta. Well, first off, let's realize that theta being between pi over 2 and pi, this means, if we move over to our unit circle real quick, being between pi over 2 and pi puts us right here in quadrant 2. Okay, because here's pi over 2, there's pi. So we are in quadrant 2. So let's make note of that. We were given that the cosine of theta equals negative 3/8. Well, let's go ahead and set up quadrant 2. Okay, we know in quadrant 2 we have negative x values and positive y values. Let's draw our triangle in quadrant 2. Notice that the hypotenuse is coming from the origin and that we have one of the legs falling on the x-axis, the adjacent leg. Here's our angle theta, here's our right angle, and we know again that cosine is negative 3/8. Cosine of theta equals negative 3/8. And we also know that cosine is the adjacent over the hypotenuse. So that means the hypotenuse has to be 8, right? Because hypotenuse 8, both in the denominator. And the adjacent leg is going to have a length of 3. Now, it's important to notice this negative here, and we're on the negative side of the x-axis, so that adjacent leg is going to be negative 3. Now, since we're trying to find the cotangent, I know I'm going to end up needing the opposite leg to theta. So let's go ahead and work on finding that. So for the opposite leg, we're going to take the leg that we know, negative 3, square it. The leg we're looking for, I'm going to call x, equals 8 squared, the hypotenuse. Negative 3 squared is positive 9. 8 squared is 64. Subtract 9, we get x squared equals 55. And then taking the square root of both sides, we get x equals the square root of 55. Notice that since 55 is 5 times 11, and neither 5 or 11 are perfect squares, square root of 55 is already simplified. Also notice that the square root of 55 will be positive because it's running on the opposite leg, and we are on the positive side of the y-axis. Once again, keep in mind that the adjacent leg, which is on the x-axis, is negative because we're on the negative side of the x-axis. Okay. So now, lastly, again, the whole point of this is to try to find the cotangent of theta. That's our goal. Find cotangent of theta. So the cotangent, we know, is the reciprocal of the tangent. And if tangent is opposite over adjacent, cotangent is adjacent over opposite. That means that the cotangent is the adjacent, which is -3, divided by the opposite, which is square root of 55. We know we don't like square roots in the denominator, so multiply by square root of 55 over square root of 55. And this will give us -3 square root of 55 over 55. Oh, don't like that. Let's try one more time here. Oh, that's going to be terrible. That's going to bother me. Yeah. Okay, and that is option